Hello, welcome to this lesson where we are looking at the surface area of a cone. And then before I explain, let me give you these notes. For those of you that are copying these things and you are following these lessons, write down these notes. I don't have enough space on the board. Write down these notes from the calculate the surface area there as up to the worked example here where we have a formula. Write down these notes, okay? Then after that, we can look at the work now. So, the cone is a composition of these two shapes here. We have the curved surface as well as a circle. This is a curved surface and a circle. So when we combine the two, we have this curved surface and a circle that is at the bottom. Alright? So you should understand that that is where a cone is coming from. It is a composition of a curved surface as well as a what? A circle. So to find the area of the total surface area of a cone, we need to find the area of the curved surface as well as the area of a circle. So we need to look at the formulas that are involved here. The formula to find the area of a circle, we use this formula. This is the formula that gives us the area of a circle. Please take note. And then the curved surface, we have pi r L. R is the radius, even here R is the radius. L is the slant. L is the slant height of the curved surface. L is the so there are questions that I've seen in the exam where they are just asking you to find the area of the curved surface. The area of the curved surface. That doesn't talk about the whole cone. We're talking about the area of the curved surface. Please, when we have such a question, we are going to use this formula. The area of a curved surface of a cone. We just want the area of a curved surface. But if we are talking about the area, we want to find the total surface area of a cone. The total surface area of a cone. Like I said, that a cone is composed, or it is formed from these two. We have the curved surface and the circle. So to find the total surface area of a cone, we need to find the area of this one as well as this one. Then we add them together. That is what is going to give us there. So in this case, we have what? The area of a circle, which I gave you here. The area of a circle. The area of a circle. This is the area of a circle here. So to find the area, total surface area of a cone, we need to add these two formulas. We're going to have area of the curved surface area plus area of a circle. Because these are the two areas, these are the two shapes. These formulas, they are coming from these two shapes that form the cone. So this is the formula that we use to find the total surface area of a cone. We use this formula that I've written down here. The only other thing that you can do, or that has been done, is where you look at what is common here. Pi is common as well as r. So you say you factorize. Then you remain with L plus r here. So this formula, these two formulas are the same. But one thing that I want you to know, like I already emphasized, is that there are times when we talk about this curved surface area of a cone, we should confine ourselves to this formula alone. All right? So, let us look at the examples. And you should be able to understand now here. And I should explain. There are times when you should know that in this formula, L is what? L is the slant height. L is the slant height. This slant height. Okay? L is the slant height. The L in the formula of a cone, it is the slant height. You have a cone here. Okay? You have a cone here. This is the radius from this point up to this one. This is the radius that we are talking about. This is the radius. Oh, are we together? Now, if you have been given the diameter, you need to know that what you need in the formula, it is not the diameter but the radius. And I did mention the relationship between diameter and radius. That diameter is equals to 2 multiplied by radius. Because radius, we are saying, is the distance from the circumference up to the center of the circle. Then the diameter divides the circle into 2. So when you have been given the diameter, you should know that what the formula needs is the radius. So you should divide the diameter by 2. Okay? And then the other thing is that the slant, what we need here is the slant height. The slant height, which is this one. So in this case, we have L and D. Okay? It's important to take note here. This is our R is here and our L is this one. This L is the slant height. Then R is our radius. So in an event where you've been given diameter, you should be able to find it. Now, there are questions that we are going to even look at, or questions that are given in the exam where the examiner will give you, this one will not be there. Instead, they are going to give you this one. And what is this one called? This is either called the vertical. This is either called vertical height or perpendicular height. But what we want is the slant height. Okay? But what we want is the slant height. So you should be able to know here that we have, if we have this case, this is our slant height. This is our slant height, and then this is our radius. I'm getting it from this. Then this is our h, which is the perpendicular height or the vertical height. But what we want, what we need in the formula, we want the slant height. So we should use the vertical height or perpendicular height as well as the radius to find the slant height. And we are going to use the Pythagoras theorem. Okay, so let's begin to look at the examples without wasting time. Let's begin to look at the examples without wasting time. Are they clear, these things on the board? Okay, I think so. Okay. So a cone has a slant height of 12 centimeters and the radius of its circular base, okay, is 5 centimeters. Calculate the total surface area of a cone. So it has been given in words, but we can come up with a sketch because sometimes in the exam a cone will be drawn for you. So we have this cone, and then we have, okay, we have this case. This is our cone here. And what have we been told? The radius is what? The radius is 5. Okay? The radius is 5. Then the slant height. Take note, what we want is the slant height, and the question has given us what? The slant height. So in this case, we have been given everything that is required for us to work out the total surface area of the, so I'm going to say total surface area of a cone. You know that we came from, I told you that we've got these two formulas, plus you can either use this one as it is here. R is our radius, then this L is what? Pi. Pi, in most cases in paper 2, we use 3.142. So we'll take this as our pi. So we can use this formula here, okay? We can use this formula and see what we are going to get. In most cases, these questions do come in paper 2, so we can use a calculator and work out. Okay, either way, or if we want, we can as well factorize this, and then you say we have plus, then see whichever we're going to use. So let's go with 3.142 multiplied by r, which is 5, open brackets. We have what? The slant height is 12 plus r. So let's work out this thing on our calculators. Make sure that you have your calculator. So we have 3.14 3.142 multiplied by 5, open brackets, open brackets, then we have, even without opening brackets, we can say, okay, multiplied by, when you add these, you know, we're going to get what? 17 multiplied by 17. What are we getting? We're going to get 267.7. What are we talking about? Area, centimeters squared. This is what is going to be our answer. I hope that is what you're also getting. I hope we are getting the same thing. This is what is going to be our answer. Well, when you have been given the slant height as well as the radius. Okay? So, don't be distracted. Don't be distracted. Don't be distracted in an event where the cone has been written or drawn upside down. You begin to ask yourself, what is this? We can still have such a case where we have it like this. The idea is the same. So I want us to look at the second question. I want us to look at the second question. So, a cone has a perpendicular height of 4 and the diameter of its circular base. Let me write the cone here. Let me draw the cone. This is our cone. This cone has a perpendicular. Perpendicular height is different from the slant height. Slant height is this one. Perpendicular height is this one that comes from, that starts from the center of the cone and it runs up to the apex here. This is the perpendicular height, this one. This is the perpendicular height, okay? This is the perpendicular height, which is what? 4 centimeters. That's what has been given in the question. And we have also been given that the diameter from this point up to this one, it's what? 6. It is what? 6. But you should know that for what we need, as what we need in our formula, it's radius. And radius, we have to divide that diameter by 2. So, I'm going to take it that I will ignore this other part and get my 3 here. Where did it come from? I've told you that we've divided 6 by what? We have divided 6 by 2. And now, remember that our formula here has the slant height and radius. The slant height, it is this height here, which we do not have. So we need to find this height. We need to find this height using Pythagoras theorem. You understand? So we are going to extract this triangle. This is our 3 and our 4. Okay? Now, our slant height is, if you remember our Pythagoras theorem, we say the square of this one is equals to, if I take this side as h, then I take this one as what? B. Okay, let's say this is our r, which is radius. Okay? So this is equals to r squared plus h squared. Okay? So meaning our L is going to be equals to r squared plus h squared. Okay? This is our L. And I want you to get to know that. If you are given this, now there are times also, I must make mention here, there are times when you are going to be given the perpendicular height as well as the slant height, but then radius is not given. So we should be able to see that from this point here, when we want to make this radius the subject of the formula, it will mean that radius squared, r squared, is equals to, this one will have to come the other side here, minus, okay? So meaning, this will mean that for r, if you are going to need r, it will be r is equals to, you square these two, L squared minus h squared. L is what? Our slant height. L is our slant height and h is the perpendicular height. And you should remember that to find the area, the total surface area of a cone, you need what? The radius. And that is what I'm trying to do here. In an event where the question gives you the slant height as well as the vertical height or perpendicular height, you need to find the radius of the circle, which is going to be found by using this formula here. So we are using Pythagoras theorem to work out those things. So that is what we are supposed to do. Okay? That is what you are supposed to do. In this case, I'm considering a case where these two are not given, so you have to find them using Pythagoras theorem. So let's go and look at this case. The question, we were given perpendicular height as well as the diameter, which helped us to get radius. Now we need to find L, which is the slant height because it's not given. We need to find the slant height because it is not given. So please, I'm appealing to you, write down these two formulas. When it comes to area, you need this formula as well as this one. Write them down nicely like this, okay? In an event where you need to use them, you should be able to apply them. Okay, so in our case, the formula that we are going to apply, we said L is equals to the square of H, which is we said what? The square of R plus the square of H. And this goes to the square of 3 plus the square of 4. This goes down as 9 plus 16. And this gives us 25. The square root of 25, you can use our calculator. It will give us what? The square root of 25, we're going to get 5. Okay? We have our calculators here, so we go to this pattern. The square root, then you type your 25 here, equals. Then you're going to have your what? Your 5 there. So sometimes we may have difficulties. So now we know what we found our radius, it's 3 after we divide the diameter, and our L is now 5. You see? So there's a process that you need to work out these. Now at this point we can go on and do what? Work these questions out. And like I was mentioning, the first question is asking us to find what? The first question is asking us to find the curved surface area. I mean the area of the curved surface. The area of the curved surface. Okay? Area of the curved surface. Okay? Area of the curved surface. Or in other words, it was going to be the curved surface area. Okay? But then here we have area of the curved surface. And I have told you that when we are talking about area of the curved surface, we are using this formula. And the process is the same. in this case, we have already found what our L is. So we are going to say our pi is 3.142 multiplied by radius, which we found as 3 multiplied by 5. So 3.142 multiplied by 15. We can use our calculators. Make sure you get the same answer here. You can pause and find yours before you look at what I'm getting. You will never know these calculators. So for me, I'm getting 47.13 centimeter squared. Okay? So this is the what? The area of the curved surface. This is the area of the curved surface. This is the area of the curved surface. Then now we want the total surface area of the cone. We want the total surface area of the cone. Remember that the total surface area of the cone is equals to the curved surface area plus the area of the circle. Remember, the curved surface area plus the area of the circle. So this we have already found. What did we find here? We have already worked out this part here and we got 4. It's the same, so we don't have to go. Then we work out this part now. Okay? We work out this part. We work out this part and get multiplied by the radius, which is 3. 3 multiplied by 3, it's 9. 3 squared, it's 9. So we can say this plus 3.142 multiplied by 9. What are we getting? Here I'm getting 7.480. These questions in the exam, sometimes they would want you to round them off to 3 significant figures. So if you are talking about 3 significant figures, it will be 17.4. Okay? It will be 17.4. So alternatively, if you wanted, even without replacing this part, you were still going to say, let me use this formula as it is. Because this is the formula for the total surface area. This is the formula for the total surface area. I'm sure you should still be able to get this is 3.142 multiplied by radius, which is 3, open brackets. Then you've got 5 plus 3. Are we going to get the same? Okay? What are we going to get? Let's try in case someone goes straight. 3.142 multiplied by radius, which is 3, multiplied by, what do we have here? 8. Multiplied by 8. Yes, you're getting the same thing. You're going to get the same thing, which is 75408, which reduces to what? 754 point. If you are looking at 3 significant figures, this is what we are going to get. Okay? I hope it's clear. I hope you are able to see. Oh, yes. Okay. So let's look at the last example. The last example. Find the slant height of a cone. Find the slant height of a cone. Of a cone of curved surface area. The curved surface area is already given. We have a cone. Find the slant height of the curved surface area that has got radius what? Radius is 3. Now, please can we pay attention? The question, what have we been given in the question? In the question, we've been given the slant height. We have been given the curved surface area. Curved surface area, like I told you, that it is this formula. This is the formula that gives us the curved surface area. This is the formula that gives us the curved surface area. So we have to make sure that we use just this part of the formula because we are talking about curved surface area. So this curved surface area is equal to what? 20. Okay? Is equal to 20. Are we together? Is equal to 20. So what is our slant height? Our slant height there, we are going to say 3.142. The radius has been given as what? 3. This is equals to multiplied by L, and this is equals to 20. So, is equals to 20. So to get this one, we need to divide both sides by 3.142 multiplied by 3. So L, which is the slant height, is equals to 20 divided by 3.142 multiplied by 3. You put these in brackets like that. Okay? You put those in brackets. So let's try. Let's do this. 20 divided by, open brackets, 3.142 multiplied by 3, close brackets. What are we getting? We are getting the slant height is equals to 2.12179, goes on like that. So when you round off to 3 significant figures, it's going to be 2.12 centimeters. Okay? So, if you want now, you can try to put this thing here and multiply by these. You see if you are going to get 20. Alright? You see if you are going to get 20. You have that whole thing which we got multiplied by 3.142 multiplied by 3. So we're getting 19.9 watt, which is the rounded to to the whole number as the 20. So this is what we are supposed to have. I'm sure these examples have helped you to get the concept on this part, and you cannot fail to handle any question in the exam. Please make sure that you subscribe to this channel so that all the videos that we're uploading, you are watching them in order to make sure that you write your exam without complications. Okay? Give us some comments on how best we can provide this service to you. I'm sure I've tried to give something there that would be helpful to you. So let me give you some questions. This question came in paper 1. I want you to look at it. First one. Just the first part, A. Should be able to do A. It did not require you to use a calculator. There's also this question here, C. Just look at C. I want you to look at C. This was 2016 paper 2. Okay? So it's 2016 paper 2. Then if you want, just for practice, you can also look at these questions on this page. This is Progress Grade 11. They can help you just for practice. Okay? Otherwise, thank you so much for watching.